All right, so this is our lesson on geometric series. So there it starts with warm-up, pretty long warm-up. It's a few problems. So go ahead, pause the video, try those, and then come back, see how you did. All right, let me go back to them here. So here are the first two. Okay. And here are the next two. Okay, all right, so as we have seen before with arithmetic sequences and series, there is a formula that you can use for a geometric series. This formula will help us so that we don't have to plug in 1, plug in 2, plug in 3, plug in 4, and so on and so forth, and then add them all up. We can use this formula that will do it for us. Now, if plugging in 1 through whatever is faster than using the formula, obviously you should do that. So if it's like plug in 2 through 3, or plug in 2 through 4, or plug in 1 through 3, that's only plugging in 3 numbers, right? So it might be faster just to plug in those numbers. You decide, right? But sometimes, most of the time, it's faster to use this formula. So the sum for a finite geometric series, where a sub 1 times r, a sub 1 times r squared, so on and so forth, with a common ratio r not equal to 0, what does it say? Or 1. Yes, obviously not equal to 0, 1, is, and then here's the formula. Okay, now I emphasize finite, meaning that it doesn't go on forever and ever. We're going to see a different formula completely if the sum goes on forever and ever. All right, so here is the formula. The sum of the number of terms, so the sum of the first 80 terms, however many terms is, what you do is you take the first term in that series, and then you multiply it by 1 minus r, which is your ratio. So if it's times 3, then it would be 3, to the nth power, divided by 1 minus that ratio. Notice I have this r in parentheses here because it could be a negative number, right? Or it could be a fraction, and we want to make sure we have that ratio in parentheses. Okay, so here is our first example. It says find the sum of the geometric series sequence. It should say geometric series, but it's fine. And the directions don't even have to say that. I know I'm talking a lot before I even do the problem, but if it's just said evaluate or find the sum, let's go back to evaluate. This sigma means it's a sum, okay? Now also let's make sure we recognize it as geometric, right? This is 4 times 0.3 to the nth power. So that was weird. Since it is an exponential function, meaning that your variable is in your exponent, this is an exponential function, therefore it's geometric. Okay, it's also in that familiar a sub 1 equals r to the n minus, it doesn't say n minus 1 power though. So I do know that this is my ratio, but that may not be my first term. That might be my 0th term. Okay, a lot of talking, not a lot of moving here. So let's go ahead and start. So I need the sum of, this is 12 terms. This is going to be faster than plugging in 1 through 12. Well, with the amount of talking I did, who knows? Now, my first term is a sub 1, so I need a sub 1. If this was n minus 1, then a sub 1 would be 4, but it's not, so I have to plug in 1 to see what I get. When I plug in 1, I get 4 times 0.3 to the first power. So I can use my calculator to do this. I can use mental math. It's up to me. 0.3, and I get 1.2, right? So you could either write it as a decimal or write it as a fraction. We're going to end up plugging into our calculator, so it doesn't matter to me. All right, so we have 1.2, right? Or you could have 6/5. It's up to you. Times 1 minus your ratio, which is 0.3. So since it's a positive 0.3, I really don't need to have it in parentheses, to the nth power, which is 12, divided by 1 minus 0.3. All right, so now we're going to put this in our calculator, okay? All right, so first thing I'm going to do is I am going to do 1 minus 0.3. I can do it with mental math, which is 0.7. The reason I do that with mental math or get it right away in my calculator is otherwise I'd need another set of parentheses around this. So, oops, I don't know why, which I don't want to do right now. Okay, so I'm going to start by typing my numerator. I'm going to do 1 minus, I technically don't need the parentheses and the 0.3 since it's a positive and it's not a fraction, but, you know, I'm going to do it anyways. 12th power, enter. Divided by 0.7, enter. And then I'm going to hit times 1.2, enter. There's my answer. We're going to round to 3 decimal places, so we should probably say approximately, because this is not exact, 1.714. Now we could check to see if this comes out to a nice fraction. Math, enter, enter, and then write that answer, but I don't. It does, it just won't fit in our calculator, so we have 1.714. Okay, all right. Let's look at the next one here. All right, so we want the sum of the first 11 terms. And if you're like, what, 11? Yeah, sum of 11 terms. 0 through 10 is 11 numbers, all right? All right, so now we need the first term. The first term is a sub 0, all right, not a sub 1. And a quick way of getting n there is to subtract those two numbers, 10 minus 0, right? And then add 1 to it. All right, so that is 11. So like if I wanted to do this one, all right, I can do 12 minus 1, which is 11, and then add 1, which is stupid, but it's fine. Okay. Okay, a sub 0 is 3 times 1.5 to the 0 power, which is 3. Okay. And now I can start. So my first term is my 0th term. It's not a sub 1. If this was 1, my first term would be a sub 1. All right, so I have my first term, which is 3, times 1 minus my ratio, which is 1.5, to the 11th power, divided by 1 minus 1.5. All right, once again, I'm going to do a little mental math. 1 minus 1.5 is negative 0.5. And now I'm going to use my calculator. All right, 1 minus, parentheses, 1.5, parentheses, to the 11th power, enter, divided by negative 0.5, enter, times 3, enter, and I get 512. And once again, we're rounding, so you could put approximately, you can put equals to, it doesn't bother me. 112.985. I can check to see if it comes out to a nice fraction, but once again, oh, it does. I was going to say, once again, it doesn't. So I'll say, or S sub 11 is equal to 525. I wasn't ready for that to be a fraction that fit on the calculator, over 1024. I'm assuming most people will put the decimal, but you can do either one. Doesn't matter to me. Okay. All right, find each sum is the next direction, I'm assuming. Yes, find each sum. And then it says, use a formula if possible. All right, so there's 6 problems here to do. If at any point you're like, I got it, try it on your own, okay? All right, so looking at the first one, I want to know if I can use a formula because it says use a formula if possible. This is arithmetic, so I can, arithmetic, I'm going to write that down, arithmetic. So I can use a formula, right? So I'm gonna, right? So let's remind ourselves of what the formula looks like for arithmetic since we just did geometric. It is n divided by 2 times a sub 1 plus a sub n, okay? So first off, I need to know how many terms there are here, okay? So what I'm going to do is I'm going to do 74 minus 15 to figure out how many that is, and then add 1 to it. So 74 minus 15 plus 1. I should probably leave space for this. N is equal to 74 minus 15 plus 1. So 75 minus 15 is 60. No, that is not. Yes, that is correct. 60. I thought it was not correct for a second, but it's correct. Okay, so there's 60 terms. So I'm finding the sum of the, not first 60 terms, but I'm finding the sum of 60 terms. I'm doing 60 divided by 2. And then I need a sub, I should say 15 plus, oh, that's the formula. It's fine. So for mine, I need a sub 15 because that's my first term, plus a sub 74 because that's my last term. Hopefully that's making sense for you. All right, so I'm going to go off to the side and do a sub 7 or a sub 15 5 times 15 minus 3. That is 72. And then I'm going to do a sub 74 is 5 times 74 minus 3. I'm going to use my calculator for that. Minus 3 is 367. Five times 74 minus 3. Yes. Okay. So now I can find the sum. Oh, is that supposed to be? Yes, no. Okay. All right. So now I'm going to go ahead and find this sum. Okay. So let's put it in our formula. So we have 30 times 72 plus 367. All right, calculator time. All right, so 72, I should just type it the way it is. All right, so 30 times, parentheses, 72 plus 367 equals, all right, 13,170. So the sum of, it's not the first 60 terms, but the sum of those 60 terms is 13,170. Okay, so common mistakes, let's talk about them. Using a sub 1 here because the formula says a sub 1, but remember this means your first term in the series, which our first term is the 15th term. And then this is our last term. So common mistake there is using 60 on accident because they want to match this. But remember your last term in the series is what you get by plugging in 74. Okay? All right, let's move on to this next one right here. So this right here is geometric. So I'm going to go back to using my geometric formula. All of these formulas you do need to know for your test. So the sum of, I'm not going to write it since we just learned it. But for this number, our n is going to be 5 minus 0 plus 1, which is 6. 0 through 5 is 6 terms. So 6 terms is equal to. And then for our geometric series, we have our first term, a sub 1. So we need to plug in 0 for n, a sub 0. We need to plug in 0 for n and see what we get. So we have 16 times, and once again, if this was 1, then my first term would be 16, but it's not, okay? 16 times negative 1/2 times 0 minus 1. So that is negative 2 to the negative first power, which makes it flip, which is negative 2 times 16, which is negative 32. You could use your calculator to get that, of course. I was just trying to do a little mental math. Let me make sure I am right, but I'm pretty sure I am. 16 times negative 1 divided by 2 to the negative first power is negative 32. Okay. All right, so my first term's negative 32. Times 1 minus my ratio. This is where it's important. It's negative and it's a fraction. And then the number of terms is 6. And then 1 minus a negative 1/2. Okay. So first thing I'm going to do is my mental math, right? Or I can get it from my calculator, but this is mental math. Let's be serious. This is 1.5. Okay. You can put 3 halves if you want, but guess what? We're using a calculator, so I don't care. All right, so now I'm going to type in the numerator. Those parentheses are extremely important. Do not skip them. 1 minus a negative 1 divided by 2. Big mistake people will make is that they will say, oh, double negative. I'm going to just make it a positive. No. It's negative 1/2 to the 6th power, and then 1 minus that, okay? So you get that, which I now need to divide by 1.5. And now that I need to multiply by negative 32. Enter. And I get negative 21. Wow, I wasn't expecting that answer, but it's okay. S sub 6 is equal to negative 21. Well, the first term is negative 32. Yeah, and you're only taking half of it, then it's not that crazy. Okay, or negative 1/2 of it, so that's not a crazy answer. Okay. All right, let's keep going here. Okay, this is not geometric, nor is it arithmetic. If this wasn't here, hey, now it is arithmetic because that's linear, but it's not geometric. If it was 2 to the n and this wasn't here, then it's geometric, but this is a quadratic, okay? So there is no formula. So what we're gonna have to do is we're gonna have to plug in 3, plug in 4, plug in 5, plug in 6, plug in 7, and then add up all of our answers, okay? So we're going to plug in 3 first. I wrote these down as 3, 4, 5, 6, 7, so I don't forget what to plug in. Plugging in 3, I have 9 minus 3, which is 6. Plus plugging in 4, I have 16 minus 3, which is 13. Plus plugging in 5, 25 minus 3 is 22. 36 minus 3 is 33. Plus 49 minus 3 is 46. Add those up. So 79 plus 22 is 99, plus 2 is 101, 114, 120. Okay, double checking my calculator, but I feel good about it. Okay, next one, geometric. I see an exponential function, so this is geometric. So I am going to use my formula, but once again, if you want to plug in 2 through 9, that's you. Okay. All right, so the sum of, I need to know how many terms this is. So I'm going to do 9 minus 2 plus 1, which is 8. All right, 9 minus 2 is 7. 7 plus 1 is 8. There's 8 terms. So I'm finding the sum of 8 terms, which is equal to, I need my first term, which is a sub 2. So if I plug in 2 there, I got 2 times 3 squared. So 3 squared is 9. 9 times 2 is 18. So my first term is 18 times 1 minus my ratio, which is 3 to the 8th power, over 1 minus 3. All right, mental math first, negative 2. All right, 1 minus 3 to the 8th. I notice I didn't need parentheses there because it's a positive 3. Divided by negative 2, and then times 18. All right, the sum of those 8 terms are 59, 040. All right, so let's move on to the next one. Okay, so the next one's in a different format, right? There is no sigma notation. So we need to approach this differently. Okay, so what I'm going to do is I'm going to say, all right, is this arithmetic or geometric? There's no rule written, so I'm going to also have to write a rule so I can figure everything else out from there. So if I look here, it's plus 6. So my D value, my difference is 6, and my first term is 5. So I'm going to start by writing a rule because I know I'm going to need it, right? A sub n is equal to my first term, which is 5, plus n minus 1 times d, which is 6. So this is 5 plus 6n minus 6. So my rule that this is following is 6n minus 1. All right, so if I wanted to write it in sigma notation so I can get used to what I've been seeing, I know this is 6n minus 1. And then when I plug in 1, I get my first term, which is that 5. And then I want to know what term number this is. So what I'm going to do is I'm going to do 6n minus 1 is equal to 443 and solve that. So I have 6n is equal to 444. And then 444 divided by 6 is 74. So that's my 74th term. Okay, now I can treat it just like the other ones, right? So let me get a different color going here so it doesn't blend. I'm going to do green. All right, so the sum of that 74 terms is equal to, and then remember, it's arithmetic. Let's write that down. Arithmetic. So that's the number of terms, which is 74 divided by 2, times my first term, so I'm plugging in 1, right? So I need a sub 1. That, I don't need to do this. This is a sub 1. This is a sub 74. So I have 5 plus 443. Okay. Now you might be saying, wait, did you even need that rule then? Yeah, I needed the rule. Why did I need the rule? To get this 74. Otherwise, I would never know it's the 74th term. Okay, so now I'm going to do 74 divided by 2, which is 37. And then 37 times 5 5 plus 443. And you get 16,576. So the sum of those 74 terms is 16,576. All right, last one in this section, then we'll move on to infinite geometric series. 5, 10, 20, so times 2 times 2. So this is R is 2. So this is a geometric series, so I'm going to use my geometric formula. So the sum of, well, I need to write a rule because I don't know what number term that is. So we have a sub n is equal to a sub 1, which is 5, times r to the n minus 1 power. All right, so that's my rule. And now I need to figure out, so I'm going to write it in sigma notation. You don't have to, right? But I just like to. When I plug in 1, I'll get my 5. But then what do I plug in to get 40,960? In my rule, 5 times 2 to the n minus 1. Okay, so let's go ahead and figure that out. I'm going to do that off to the side. 5 times 2 to the n minus 1 is equal to 4960. Divide both sides by 5. I'll just use red. All right, so 4960 divided by 5 is 2 to the n minus 1 power. Let's put my 2 in there. Is equal to 8192. Now, there is a way to solve this, which we're not in that chapter yet, which is using logarithms. So we're going to use good old guess and check. So I'm going to say 2 to what power gives me that number. So I'm going to try 15th power. I'm too high. So I'm going to do 2 to the 14th power. And I'm still too high. So 2 to the 13th power. And there we are. So I'm going to say this right here is 2 to the 13th power. So I have 2 to the n minus 1. I should probably move it a little bit away from that so it doesn't blend. Is equal to 2 to the 13th power. So be careful here because n is not 13. N minus 1 is 13. So n is 14. All right, so 14. Once again, there is a more algebraic way of solving that. It's called using logarithms, but we're not in that chapter yet. All right, so now I'm going to find the sum of this series right here. Okay, so it's geometric once again. Not once again, but it's geometric, as I said before. That is the 14 terms. All right, so I need my first term, which is 5. A sub 1 is 5. Times 1 minus my ratio, which is 2 to the 14th power over 1 minus 2. See, once you got those things, it's not a big deal. It's a negative 1. All right, so 1 minus 2 to the 14th, enter, divided by negative 1, enter, times 5. Enter. 81,915. So the sum of those 14 terms is 81,915. Love it. Okay, so how many problems do we have left? Oy, not that many. It's only 4. Okay. All right, so last thing we have to talk about is the sum of an infinite geometric series. Okay. So it says if a geometric sequence of terms converges to 0, then we can find the sum of this infinite geometric series. Start with the geometric series formula. Okay, so what that means, right, is that we're looking at this right here, a sub 1 times 1 minus r to the nth power. Okay, so let's pick an r value of trying to 0.5. Okay, I was trying to think of something easy to type in the calculator. So we're at half, right? Times a half, times a half, times a half, times a half. Okay. So what I'm going to do in the calculator is I'm going to do 1. I'm going to do parentheses. Try to explain this. In parentheses again. 1 minus, I'm going to do my 0.5 to some power. Okay, I'll do to the 10th power. And then divided by 1 minus 0.5 is 0.5. I don't need that parentheses, I guess. And I get 1.998. Okay. And then I'm going to do 1 minus, actually, yes, I'm going to keep going. Should I keep showing this? Am I wasting people's time? I don't know. We'll find out. 1 minus 0.5 to the 100th power. Enter. Okay, so I didn't even need to show the denominator. So basically as n, this is a terrible example. So I'm going to do 1 minus 0.5 to the first power, right? So no, let's do second power. So that is with two terms, you get 0.75. 1 minus 0.5, oopsies, 1 minus 0.5, this is like the world's worst explanation. To the 10th power, I get that. 1 minus 0.5 to the 15th power, I get this. Notice that it's getting closer and closer and closer to, right? 1 minus 0.5 to the 20th power, I get that. 1 minus, making the world's longest screencast, 0.5 to the 100th power, okay? And all of a sudden it's like, you know what, 1, okay? So basically it's converging to 1, okay? And what we can, this is going to end up converging to 1, and therefore, this is the worst explanation ever. We are not going, this is going to be 1, okay? If that's 1, we don't need it. Terrible example. But, because it goes on forever and ever and ever, right? I put in 100. I couldn't even put in infinity, right? Like, I can't put in a number infinity. That's not a number. I just put in 100, and all of a sudden, it was like 1, right? So that's going to turn into 1. And then we have a sub 1 in the numerator, right? Because why not write it in the numerator over 1 minus r? That was a terrible explanation. But, long story short, if you, so actually let's write this. If I do a sub 1, let's write it in front, because I will try to re-explain what I just did. 1 minus r to the infinite power over 1 minus r. This is going to turn into 1, which is going to give us a sub 1 over 1 minus r. That was a little bit better of an explanation, but still it was horrible. Hopefully you fast forwarded through it and said, what an idiot. Okay, so the sum of an infinite geometric series, that's our formula. Now, that is if r, the absolute value of r is less than 1. Okay, if the absolute value of r is less than 1. So what we have to keep in mind is that what if it's not less than 1? What if it is greater than 1? Okay, so think of numbers greater than like 2, and we'll get to that in a second. Okay, so let's write down, when I say absolute value of r is, I'm babbling, is less than 1, that means that my r value is in between 1 and 1. Okay, that's what that means. Not including 1, not including negative 1. Oops, that made no sense. Negative 1 and 1, right? It's in between negative 1. So like negative 0.6, okay. Positive 0.6, okay. 2, not okay. So what we say for this is that it converges. Converges. And we can use this formula. It converges because it's going to end up making that r value 1. Now, if r, the absolute value of r is greater than 1, then that what we say is that it diverges. And if it diverges, then we do not use this formula. So think about that if it's like times 3, right? So if you keep multiplying by 3, multiplying by 3, multiplying by 3, multiplying by 3, multiplying by 3 forever and ever and ever, the number is just going to get bigger and bigger and bigger and bigger. And if you keep adding it to a sum, that just keeps getting bigger and bigger and bigger. So it's just actually going to sum to infinity, which is not an actual number. And same thing if it was approaching negative infinity, it'd sum to negative infinity. Okay, great. Terrible explanation, but let's see what I can do here in the future. I'm sorry. Let's just know that this, when you see, here's a better explanation. Hopefully you looked at the formula. Know that we have to use this formula right here. I'm trying to calm my voice down because I'm kind of upset with myself. We have to use this formula when it's an infinite series, geometric, and the r value is in between negative 1 and 1. If it's not, then I'll show you what to do when we get there. Okay, so this is an infinite geometric series. Okay, so it's an infinite geometric series. So we're going to say the sum of the geometric series is equal to. So now what we're going to do is we're going to look at the r value. So R is in between -1 and 1, so it does converge. Okay, so you are going to use that formula up there. So the formula is a sub 1, right? And we're using a sub 1, so the first term, which is -5 over 1 minus R, which is 1/2. Okay, do your denominator first always, right? Because that's some mental math. Otherwise, you have to put it in your calculator like this. So this is 0.5. And then we have -5 divided by 0.5, which is -10. So the sum of this infinite series is -10. Now you might be saying, what? Wait, how? Why? We keep taking half of a number, half and half and half and half forever. But at some point when you take half of something that's hardly even there, it doesn't even matter anymore. So it does converge to -10. Okay, hopefully you didn't leave my screencast already. All right, let's look at this next one right here. I see that it's an infinite series. It's geometric. So now I need to know if it converges or diverges. Looking at R is 4/3. 4/3 is, let's do this, 4/3 is greater than 1. So this diverges. That's not how you spell diverges. Diverges. I don't know if that's how you spell diverges either. I think it's this. So this, when we still can find the sum. So we're going to multiply by 4/3, multiply by 4/3, multiply by 4/3, and keep adding that. So this is a number that's bigger than 1. Therefore, it's going to keep going forever and ever and ever, infinitely. Okay, let's go ahead and move on to this one. First off, we need to know the rule that it's following. Okay, but I just need to know if it converges or diverges first, actually, because if it converges, or if it diverges, then I don't even need to use the formula. So if we look here, this is -30 over 90 is -1/3. So this is R is -1/3 times 1/3, but it's the opposite times 1/3. -1/3, the absolute value, is less than 1. So this does converge. So I can use my formula. So my formula, the sum of the infinite series, is equal to the first term, which is 90. And I wrote that strangely. The first term, which is 90, over 1 minus my ratio, which is a -1/3. All right, 1 plus 1/3 is 4/3. So I'm going to do 90. Hello, calculator. 90 divided by 4/3, or that's times 3 divided by 4, which is 270 divided by 4, 90 divided by 4/3. I get 67.5. So the sum of the series, you do get an answer. It is 67.5. I'll teach this much better live. Hopefully you're there for it. Okay, lastly, right? Oh yeah, lastly. All right, what is the pattern here? Times 2. Right, times 2, yes. Okay, so my R value is 2. Therefore, 2 is greater than 1, right? The absolute value of 2 is greater than 1. So this diverges. Therefore, we're not using the formula, okay? We're saying the sum of this infinite series, since we're just going to keep multiplying by 2 and adding on to it, it's going to go on forever and ever, go on infinitely. Okay, sorry about that horrible explanation of this part. I wasn't preparing myself for it well enough. I was explaining it on a whim, but hopefully it made more sense as we went along. All right, that's it for today's notes. Go ahead and get started on the homework.